So problem 558, it's called logical OR of two binary grids represented as quad tree. So last time we solved a quad tree problem, but if you haven't seen that, I'll explain it again. What is a quad tree? Well, it's in its name itself, quad. So there will be four children for every node. So this is one node, it has four children, and each four children can have further more children until and unless we end up with a size 1, or we end up in a situation where all the values are 1. So in that case, this itself is a leaf node. We don't need to further divide it. So it's a leaf node. There's also a boolean called isLeaf. So for this particular quadtree, it's basically this one top right. It's leaf and its value is 1. If suppose this is the quadtree we are talking about, then this one is bottom left. Alright. This is also a leaf and its value is 0. And what about this whole node? In that case, this is not a leaf, and its value in that case, when it's not a leaf, it's not going to matter. It can be 0 or 1. So it doesn't matter. Uh, in this question, I'll consider the value as 0 if it's not a leaf. Finally, what is the question asking? So the question is asking to find the logical OR of two quadries. So logical OR, we obviously mean that 1 or 0 or 1 or 1, right? So in that case, we can think of a base condition. We can straight away think that this is going to be recursive, right? We have two quadries, we have to go on and on and on until and unless we find some base condition, right? What is that base condition? That base condition is nothing but the logical OR property of bits. That is, if we find a value which is a leaf node and its value is 1, in that case, what should be the no matter how the other quad tree is structured, suppose this is a 1. I'm not able to draw it right now. This is also 1, this is a 0, this is a 0. In that case, it's not going to matter because this is 1. So even if this was all 0, which it was already, right, this was all zeros, but still this is 1, right? So 0 is always going to be dominant in a logical operation. So 1 is the answer. We straight away return from that. So let me write the base condition here in the comment below, because that's the crux of this problem. If the quad tree 1 is a leaf node and its value is equal to 1, or the same thing for the other quad. So let me do this. If this is true, in that case, I straight away return. This is going to be the recursive function, so I'm returning the node itself, right? So what should I return here? I should return a new node, which will be 1 in terms of value, and it's going to be a leaf node, so I straight away return true. Finally, what is the other base conditions? Suppose this is not true, right? The next time I'm going to call the intersect function for top right or top left, whatever, it's going to be null, isn't it? Because since I encounter a leaf node, but this was not its value, that's why it was false, right? I mean to say that if I encounter a condition where it's a leaf node, but its value is 0. In that case, I don't have any base condition to catch. I'll go here. I'll have here three function like I should intersect for top left, top right, bottom left, bottom right, right? Here I will go ahead and call the null. I'll pass null as the argument back to intersect, isn't it? Because it was a leaf node, it's not going to have a children. So I'll pass null, right? In that case, if I see a null value here, I should return the other quad tree, right? If this was null, that's because it was a leaf node and its value was 0. And its value was 0 in that case. Let's see in terms of bits. If I encounter, if I am here, suppose, right? And suppose this was zeros, 0, 0, 0, 0. In that case, no matter what its value is, right? This is going to be what I need to return, the other quadtree, right? So here I encountered Q1 as null because its value was 0 and was a leaf node before. So I need to return quad 2. Similarly, here, just the other way, other case that I need to handle is this. And uh, finally, there may be one base condition more where both are leaf, right? And Q2 is also a leaf. In that case, I should return a new node, right? And its value is going to it's still going to be a leaf node, and its value is going to be Q1 value or Q2 value, isn't it? These are the three base conditions, and here I'm going to call the intersect function for all the three, uh, all the four children, and finally I'm going to return the node, the root node. Let's code this up. If so, I'm writing this base condition first. Quad tree 1 is equal to null. Return, or I can write it like this. That's better. Quad tree 2. If this is the other way, then return quad tree 1. Finally, I'm going to copy paste this itself. This is going to be quad tree 1. It's going to be quad tree 1. This is quad tree 2. This is quad tree 2. Finally, this is the base condition that I want. This is quad tree 1, quad tree 2. This is quad tree 2, and this is quad tree 1. Alright, so we're good. Now I'm going to call the intersect function is going to return something. First call it, let's call that for quad tree 1 top left. Similarly, for quad tree 2 top left, let's copy this 4 times. Let's copy the other three children. Alright, bottom left and bottom right. This is going to give me a node, right? Let me take that node. I can create a return, sorry, not return, sorry, node root node I can create, which is initially nothing. So this is be a empty constructor is going to call this one. Is false, false, and null, all null. That's what I want right now. I'll I'll call the top left portion or child and point it to initialize it to top left. Similarly, or instead of doing this, let me take it and slide like this. That will save up some code later on. Let's see. Top left, top right, bottom left, and bottom right. Alright, now I need to return a new root node, isn't it? Which is going to be the parent of these four. For that, I need a is leaf and a value for that, right? So if all these four children are a leaf node and their values are also equal, mind that when there's a leaf node, its value matters, right? So if all the four children have the same value and all of them are leaf, in that case, I should have return is leaf. I'll have a condition where I'm going to check this and I'm going to return a new node which is a leaf node and its value is one of the four children values because they are going to be equal. So it's going to be something like this. Otherwise, I'm going to say to the return a new node which is going to have any value. It's not going to matter because it's not a leaf node at this point because it didn't enter this condition, right? So it's not a leaf node. One of the children's values are different or all of them are or one of them is not a leaf node. Something is wrong, right? So at this point I'm going to return or I'm going to use this constructor and pass the value as anything. I'll pass 0. It's not going to matter. And I'm going to pass is leaf as false. I'm going to pass top L, top right, bottom L, bottom right. Finally, this is going to be my answer. And for that, this condition is going to be something like is leaf and top R is leaf and bottom left is leaf and bottom right is leaf. Finally, the values, right? So I'm going to have, I'll change a line. Its value is going to be equal to top right value and top right value is going to be equal to bottom left value and bottom left value is equal to bottom right value. Finally, this is it. It's a divide and conquer method. Let's see if this works. Until unless there's some silly mistake. It does, and this is a divide and conquer method, right? So as the name suggests, it's going to be a log n factor to the time complexity, time complex, right? It exceeds the limit. So in worst case, uh, I am going to go for a scenario where one of the values is zero and the other values is also zero. So I end up reaching all the nodes, right? So I'm going to traverse all the nodes at this point. So that's going to be O of n square or O of the number of nodes that I have, the n square n grid. So it's going to be n square, I believe, but I could be wrong. Anyways, thanks guys. That's the problem.